Hi, welcome to my video on a system of linear equations, two variables. Solved by graphing method, part 3. This part 3 ends up like a summary on the graphing. Practice means you can pause the video and see if you can come up with the answers to these and press the play to see if you're right. Solved by graphing, system of linear equations. For each below state, we have a graph here. We have two lines intersecting at a point. So the name of this system is consistent independent because the two lines intersect at a point. The slopes are different. This slope is going up to the right, so that's positive. This slope is going up to the left, so it's negative. Or you could say this slope is going down to the right. Up to the right is positive, down to the right is negative, whatever way you think about it. And the y-intercepts of these two lines are different. In other words, right there and right there, they're different. And the number of solutions is 1. And the solution set, well, I'm just going to say it's a point. I didn't put any numbers, just saying it's a point. B, we have two lines intersecting at a point, and again, it's consistent independent. Same as above, so it's the same up as there. And the slopes, again, are the same as above. Same as up there, they're different. And the y-intercepts are the same. In other words, the two y-intercepts are the same. And the number of solutions is 1, and we also have a point. So consistent independent is the name of the system, and the slopes are different because they're not parallel lines, they're not the same line. But the y-intercept of this one is the same. So you can have two lines with different slopes having different y-intercepts or the same y-intercept. In other words, this is the solution to the system right here. But the solution is the y-intercept. C, the name of this system is inconsistent. Inconsistent system. Inconsistent. E-N-T. I better spell that better. Inconsistent. That's sloppy on my part. Sorry about that. And the slopes are the same. Notice they're representing parallel lines. And the y-intercepts are different. So we have same slopes, different y-intercepts. The number of solutions, we have none. None. And the solution set is empty set. We have no solution. D, we have, notice that we can only have one line here, but if this is a system of linear equations, that means this system is consistent, dependent. Notice this one is inconsistent, and these other two are consistent, but one is consistent independent, this one's consistent dependent. The slopes are the same, because you only got one line. Well, you got one line, but you're having a system of equations. So you got two equations, but the two equations solved out to be the same line. And the y-intercept is the same. The number of solutions is many, or we can say infinite, whatever way you want to say it, infinite number of solutions. And the solution set is the equation. You write down one of the equations because there's only one equation. There's only one line, but you can have many, many equations. So one of the equations will be the solution set. And that's a review of the different systems. Now, number 2, state the value of m and b in the system of y equals 3x plus 5 and y equals mx plus b if the system is inconsistent. Remember now, an inconsistent system is a pair of parallel lines. If you've got a pair of parallel lines, then the slopes are the same and the y-intercepts are different. Okay, keep that in mind. Inconsistent system, parallel lines, same slopes, different y-intercepts. Therefore, if this is an inconsistent system, that means m has to be equal to 3 to be an inconsistent system. But also, if you think about it, b can't be the same as 5. So b is not 5. Another way to say that, b is not equal to 5. b is not 5 means what? b is any number but 5. So I could have a 2, a 3, a half, a -5, -7, anything but 5. So m gotta be 3 to be parallel lines, but also b also cannot be 5. It can be anything but 5. Now, a dependent system is consistent dependent. Consistent dependent is this one. So that means you got to only have one line. So that means the slopes are the same and the y-intercepts are the same. So m has to be 3 and b has to be 5 in order for it to be a dependent system. This one, you got to watch over this one. This one is good because you make the two of these the same to be the same line to be a dependent system. But look at this terminology. b is not 5. Mathematically, we say b is not equal to 5. When b is not equal to 5, it can be any number but 5. Let's continue. Practice means pause the video and work out the answers. If this system represents a pair of parallel lines, find the value of k. Remember, parallel lines have the same slopes. So the slopes are equal. So if this is equation 1 and this is equation 2, then equation 1 has a slope of 12. M is 12. Equation 2 has a slope of -6k. Remember, y equals mx plus b. So y equals 12x plus 5. M is 12. Y equals -6kx minus 2. M is a -6k. That means that a -6k is equal to 12. So when you divide by -6, you get m equals, they cancel out, you get m is -2. So, what did I say, m? I should have said k. I got a k here and I thought about m. That's because of the m for the slope. -6k equals divide by -6, k is equal to -2. And notice, put back, if you put -2 right here, -6 times -2 makes it a 12. So the answer for this question is -2. Number 4, if this system represents a pair of intersecting lines, find the value of k. Intersecting lines have different slopes. Different slopes. So let's call this equation 1 and call this equation 2. So equation 1, the slope of equation 1 is k. Equation 2, the slope is 9. So, remember, they had to have different slopes. So that means if you make them equal, they'd be parallel lines, provided b is different. And let's see, so we have to have different slopes. That means that k is not equal to 9. To be different, k is not 9. K is not equal to 9. What does that mean? You can have any value for k, but not 9. Okay, just a little bit different in the terminology. Check with your teacher if you find yourself getting mixed up, and see if your teacher can explain, also help you out. Solve by graphing and check the solutions. Well, let's solve this on the axis. This is equation 1. This is equation 2. Let's take equation 1. So negative 2x plus 4y equals negative 12. We're solving by graphing, so I'm going to solve for y equals 2x minus 12. Divide by 4. Y equals 1 over 2x minus 3. Remember I'm writing it as y equals mx plus b to graph it. So I'm moving the negative 2 over to become a plus. The 12 stays there as a minus. Divide by 4, and this is the equation. Now let's take the second one, and we're solving for y. So negative 3y equals 3x minus 9. The negative 3x moves over to become plus, the 9 moves over to become a minus, and I divide by negative 3. So divide, y equals negative x plus 3. So I have the two. Notice a negative divided by negative is positive 1. Positive divided by negative is a negative 1, and I get a positive 3. So I have y-intercept of negative 3 right there, and I will slope is 1 over 2, so I will rise 1 and run 2, rise 1 and run 2. So let's draw that line so we won't make a mistake in graphing it. So here's the graph of the number 1 equation. That's number 1. And the second one, we have a y-intercept of 3 and a slope of negative 1. And let's write that as a negative 1 over 1. So the y-intercept is 3, which is right there. And we go down 1, right 1. Down 1, right 1. Down 1, right 1. Down 1, right 1. And as you can see, everything is great because I have the two of them. If I have it done right, the two of them are intersecting at this point. So let's see what that point is. If we go up here, 1, 2, 3, 4. So that's the solution. Is on a graph is 1, 2, 3, 4. And the y is here, excuse me, negative 1. So let's check to see if we're right. So I'm going to write down the first equation. And I'm going to sub in, oh, that's not negative 2. I'm going to sub in the x and the y into that equation. X is 4. Y is negative 1. Negative 2 times 4 is negative 8. 4 times negative 1 is negative 4. Negative 12 equals negative 12. So okay for that one. Let's write down the second equation. There's equation 2, and x is 4. Y is negative 1. So we multiply before we add, so we multiply to get negative 12, and we multiply to get plus 3 minus 9. So 12 minus 3 is, negative 12 minus 3 is negative 9, plus 9 is 0. So this solution is correct because it made both equations is true. Remember, when you're graphing, you can solve the equations incorrectly and get an answer, but the answer might not be true. But I solved them, got the point, picked up the coordinates, solved them, substituted into both equations, and it made the equations true. So I know that that point, the solution is the solution to the system. That brings us to the end of Solve by Graphing. If you like my video, click the like button, subscribe button, and the notification bell, because there's more videos coming your way. And visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.